In our first video on exponentials, I mentioned that exponentials grow or change faster than any type of graph we've seen so far, and we'll see it in this class. We need a way, though, that we actually can put a number to it. So we want to talk about comparing rates of change, or comparing how fast two graphs are actually changing in value. So the basic idea, we're basically finding a slope right here. So this should be a nice review of first semester concepts, but we're going to find the slope between two given points, and that's going to tell us on average how much it's changing. So for our first example here, all I'm asking for is the average rate of change for this equation from x equals 1 to x equals 4. So over that time span, and they have to give you two different x's like this, otherwise you can't find the rate of change. We need to find 2 points on the graph using those x values, and then find their slope. So if you plug in a 1 for x right here, you're going to do negative 2 times 3 to the first. You will get out a negative 6. So 1 comma negative 6 is on the graph. And if you plug in a 4 right here, let's see, I don't have a calculator handy. That'd be 4 comma 3 to the fourth is going to be 81 times negative 2 is negative 162 for my second points. So if we want to find the average rate of change on this interval here, we need to find the slope between those 2 points. So doing our simple y2 minus y1, negative 162 minus negative 6 over 4 minus 1, we end up with negative 156 over 3. And if you were to, let's see, maybe let me double check that. I don't want to tell you guys wrong in the video here. Yeah, that's right. So it'd be negative 156. And if we actually divide that out, because we oftentimes, this would be a fine answer, but it's also good to get it as a decimal. That'd be negative 52, I believe, because 3 times 50 is 1. Yeah, negative 52, which actually is pretty nice. We get a good answer here. The average rate of change over that interval is negative 52. Now, on this second problem here, I actually went ahead and just told you what the rate of change was from the same interval. So I give you a new equation. I say, hey, here's the rate of change from x equals 1 to x equals 4. Now we want to say which of these two graphs has the higher rate of change, the one that we did or the new one right here. To figure out the higher rate of change, you want the steeper graph over that interval. Well, a slope of negative 52 is a whole lot steeper than a slope of 14. Basically, you compare the slopes, but you don't care if it's positive or negative. You take the absolute value and you take the bigger answer. So our graph from number 1 is way steeper because it has a much larger slope than a graph with a slope of 14. Having a bigger number that you're raising to the power, b being bigger, makes a huge difference there. And that's what gives our graph the edge. So our graph from number 1, y equals negative 2 times 3 to the x, is going to be steeper, or has a higher rate of change.